Hi guys, welcome to another episode of Leasing File. Now in this video, we are going to do a medium level linked list problem. So the question is, given the head of a linked list, rotate the list to the right by key places. Now we can do this by a naive approach where we are going to find the tail every time and then properly place all the pointers, and we are going to iterate it over k times because we are doing it for the key places. But if we observe the problem for a little bit, we can find a better solution in a very less complexity. So if you see, after two rotations, this entire linked list, this two nodes from the last, it's cut up and joined at the very front of the list after two rotations. So that is the case. So we have to do is we have to find out this link over here, this link. If we are able to find out this node, then we are able to go is cut off this list at this point over here and bring these two nodes to the front. Then our whole process will be completed. Now another thing to keep in mind is if we look at the problem a little bit uh, in a magnifying glass, we will see that k can be any number which can be less than the size of the linked list or greater than the size of the linked list. So if it is greater than size of the linked list, we are going to take the modulus value of the number. Why I'm saying so is because let's say this linked list is of length 5, and after 5 rotations to the right, it will again come to the same place. So we are again going back to the same place after the after the length of the list's rotation. So we're going to take the modulus value and we are going to calculate it. That is going to be a final result. So as I'm going to write the code, it's going to be a bit clearer as I'm going to explain each line of the code and what it does. So let's begin. First of all, we need to find out the tail. We need to find out the tail if you want to cut it out and cut this portion of the list and join it at the first. We need a reference to this tail node. So I'm going to say over here, so tail is equals to head, and we also have to keep a length variable because the length is going to help us in the calculation on which node to stop. So to create a breaking point over there. So while the tail.next exists, we are going to increase the length plus equals 1 and tail is equals to tail.next. Now, as I've said that we need to mod the case value. So we need to modify the case value with the length. So this will give us the modular value, the last remaining that we have to do. So if the k mod the length, if k is double equals to 0, that means there is no remainder and it's an even number of iterations. So in that case, we have to just return the head and do nothing else. Else, if the approach would be, we need to stop at at the node over here. So if you see the iterations, the case value is 2 and the given length is 5. So we have to stop at not this node, but a node above that. So if we start with the breaking point node to be this one, we have to go to one node, then we have to go to two node, second node, the second approach, the second iteration. So the approach would be the given length minus the case value minus 1. That will help us to reach over onto the node. Why we are doing minus 1? Because we are already at this node over here. So I'm going to say breakpoints to be the head for underscoring range of length minus k -1. So, and we have to iterate over the breakpoint. So after doing this, we are over onto this node. Now we have all the pointers ready to just break off the list, bring the remaining list and drag it to the front. So what we're going to do, our new head would be this element. So we're going to store it and say rotated head to be the breakpoint next. This is going to be a rotated head. Now what we are going to do, we are going to take this element's next portion and point it to null because it is going to be the end of the list. So break underscore point dot next to be null. Now what we are going to do, now we have a reference to the tail over here. We have kept the reference to the tail, that's right. Now we have to add it to the top of the list. So tail dot next should be equals to head. So now this portion, this two item is come up at the very top. Now we have to return the head of the list because this problem said so. Return rotated head. Spelling mistake. Head. Okay. Now we have to do remember of an edge case. So if the head is null, we are going to return null from it. So if not head, return null. Okay. Let's run the code to check if it's working or not. Okay, let's submit the code. Yeah, it's working. So this was the linked list problem, the rotate list. Hope you guys had learned something. So catch you again in the next video. Until then.